parameterisation. What a mouthful, hey? So we'll go through here. We recall that the unit circle, when we first described the unit circle to you guys at the start of Year 11 methods, we describe a point on a circle, and the position of the point is dictated by the angle theta. So similarly, we're going to describe the motion of an object in 9E.1 travelling in a circle, and then in 9E.2 travelling around an ellipse. So we've got a number of facts there in the dot point box. So we've got the formula for it. R controls the radius of the circular motion path. W controls how quickly it goes around the circle. We've got the period, that's the time taken for one revolution. And then we've got the speed. Okay, let's get straight in. So we have the position of a falcon as it flies in circular motion around a thermal column. So you have a column of hot air rising up, and we have a falcon going around in circles. And it's given by this equation. Distances are in meters, time is in seconds. Find the position of the falcon initially. So that just means P when time is 0. So I'm going to put 0 into both of these. Now we know cos of 0 is 1. So the x value is going to be 15. And sine of 0 is 0. So P of 0 is 15, 0. And then after 3 seconds, so P of 3, that's going to give us cos of 3 pi on 6, which is the same as pi on 2, and you can just type that into your calculator as well. But 15 cos of pi on 2 will be 0, and 15 sine of pi on 2 will be 15. Okay, that's the first part. Part B says determine the speed of the falcon. Okay, so the speed is the magnitude of its velocity, and we have a formula for speed. The last dot point, it is R times W. And we're going to compare that with, in the box, we have x of t described as r cos wt, and y of t described as r sine wt. So w is the coefficient of t, r is the coefficient of the trig function. So the speed then is going to be r times w, and in our circumstance it's going to be 15 times pi on 6. And we can convert to 3 sig figs, or we can leave it as is. But that's in meters per second. I'll give a quick evaluation. 7.853. 7.85 meters per second. Very nice. Okay, so that's the speed. So it's moving in a constant speed all the way around. Part C, determine how long it takes to complete one lap. All right, so we've got the second dot point there. The time taken to complete one revolution of the circle is 2 pi divided by W. So the period, 2 pi divided by W. And remember our value of W is pi on 6. So we have 2 pi on top of pi on 6. And that's going to be 12 pi on pi, 12 seconds. Time is in seconds. Part D, find the velocity vector after 15 seconds. So just like we've been doing with parametric equations, if this is the position vector, then the velocity is the derivative of this. So the derivative of the x component. All right, so it's going to be 15 multiplied by the derivative of cos of pi on 6. That's going to be negative pi on 6 sine of pi on 6 t. Okay, so derivative of cos of f of x is negative f dash of x sine of f of x. All right, so we're taking all that methods knowledge and applying it here. And the same with this one. 15 multiplied by the derivative of sine of pi on 6 is going to be pi on 6 cos of pi on 6t. All right. And we can simplify that expression a tiny bit, but we're required to find the velocity when time is 5. Okay, so we're going to substitute 5 into both of these. And what we'll have is we'll have sine of 5 pi on 6. So that's going to be here, isn't it? And the sine value there is half, and the cos value there is negative root 3 over 2. So we'll plug both of those in. So I said sine was half, and the cos value is negative root 3 over 2. minus 15 pi on 12. So what can that simplify to? We divide both by 3. Minus 5 pi on 4. And 15 pi root 3 on 12. Minus 5 pi root 3 on 4. Okay, so when time is 5 seconds, and all I've done there, like all that can just be typed into your calculator to simplify it. When time is 5 seconds, the x value is moving in this direction with this magnitude, the y value has this direction and that magnitude, and the magnitude of this vector would be the speed, 7.85. Very good. Okay, so that's 15E.1. So, should we just do a couple of those and then come back and do E2?
Yep, sounds good.